of chemical equilibrium and equilibrium constant. Let us now understand law of chemical equilibrium and equilibrium constant. Mixture of reactants and products in the equilibrium state is called equilibrium mixture. For the reaction A plus B reversible C plus D, where A and B are reactants and C and D are products in balanced chemical equation. Concentrations in an equilibrium mixture are related by the following equilibrium equation, also known as law of mass action. That is, Kc is equals to concentration of C multiplied by concentration of D upon concentration of A multiplied by concentration of B, where Kc is equilibrium constant and expression on the right hand side is equilibrium constant expression. Let us now understand law of chemical equilibrium. At a given temperature, the product of concentration of reaction products raised to the respective stoichiometric coefficients in the balanced chemical equation divided by the product of concentration of reactants raised to their individual stoichiometric coefficients has a constant value. For example, the reaction 4NH3 plus 5O2 reversible 4NO plus 6H2O. The Kc for this reaction is given by Kc equals to concentration of NO raised to the power 4 multiplied by concentration of H2O raised to the power 6 upon concentration of O2 raised to the power 5 multiplied by concentration of NH3 raised to the power 4. Equilibrium constant for reverse reaction is the inverse of the equilibrium constant for the reaction in the forward direction. For example, the reaction 4NO plus 6H2O reversible 4NH3 plus 5O2. The equilibrium constant for this reaction is given by K-C is equals to concentration of O2 raised to the power 5 multiplied by concentration of NH3 raised to the power 4 upon concentration of NO raised to the power 4 multiplied by concentration of H2O raised to the power 6, which is equals to 1 upon Kc. If we change the stoichiometric coefficients in a chemical reaction by multiplying throughout by a factor, then the equilibrium constant is raised to the power of that factor. For the reaction 4NNH3 plus 5NO2 reversible 4NNO plus 6NH2O. The equilibrium constant for this reaction is given by K"C equals to concentration of NO raised to the power 4n multiplied by concentration of H2O raised to the power 6n upon concentration of O2 raised to the power 5n multiplied by concentration of NH3 raised to the power 4n, which is equals to Kc to the power n.